Okay, in this video I'm going to look at confidence intervals for proportions. Now in this video essentially I'm just going to hit the main points of how to construct a confidence interval. So we'll just read the question there. In a survey conducted by a mail order company, a random sample of 200 customers yielded 172 who indicated that they were highly satisfied with the delivery time of their orders. Calculate an approximate 95% confidence interval for the proportion of the company's customers who are highly satisfied with their delivery times. Now this question is actually fairly straightforward. It explicitly states here that we're asked about proportions. Okay? Proportions. So what may happen is that every so often you may have to deduce what you're being asked. Is it a proportion? Is it a mean? Is it a difference in means? In this case, we should actually be able to deduce what we're asked here from the key numbers that were given, 172 out of 200. Okay, but it's unnecessary in this particular question because we're told explicitly, but just watch out for that. So anyway, the first thing we're going to look at is the general structure of a confidence interval. Now, this is the main theme for this particular presentation. A general structure of a confidence interval is a point estimate, okay? And in this case, the point estimate is the sample proportion, p hat, okay? Plus or minus a quantile times the standard error. Okay, so we'll come back to that shortly. Quantiles are big questions, big parts of the calculation. So I won't go into them in so much detail in these particular videos because they do actually require a bit of work, and really they are more attached to the normal distribution rather than confidence intervals. The standard error is something that I will also present in a separate presentation as to where it comes from. But in this case, what I will do is actually just state the formula and show how to calculate the relevant value. Okay, so p hat is 172 out of 200, which is 0.86, which is to say 86% of the customers are highly satisfied. Now, in this particular instance, we're told we're asked for a 95% confidence interval. That is relevant later on. We are told the sample size is 200, and for particularly with proportions, we should really expect a large sample size. Here, depending on what approach you're taking, a large sample size is generally anything greater than 30. Or it depends on what course you're doing. Sometimes a large sample size is greater than 50. It depends on what undergraduate course you're taking. Some lecturers have different preferences. But it's much of a muchness. So I'll just go with 30 as the threshold for a large sample in my particular instance. Okay. So we consider this a large sample, n is greater than or equal to 30, or actually correctly should be just greater than 30, and assume that the sampling distribution is approximated by the normal distribution. Now it's always good to just sort of state that explicitly, okay? This is for the 100% full marks that you're sort of make that statement there, okay? Now, the quantiles for the confidence intervals. We're asked here for a 95% confidence interval, and really in most cases you will be asked for a 95% confidence interval in undergraduate statistics. Okay, now this is a quantile. And I sort of explain where this comes from another time, or actually this is really coming from the normal distribution. I'll actually just sort of state what I've written there. 0.975. okay, and if you're not quite sure where the 975 comes from, the 97.5th percentile, we'll save it for another time. But just to sum it up, what the number I'm looking for here is 1.96. Okay, so 1.96 is the quantile. So I have my point estimate, which is the sample proportion, the quantile. So now all I have to do is calculate my standard error. Now the standard errors quite often in undergraduate statistics exams will be given in some sort of formula sheet, but really after a while what you should do is have a lot of them sort of be very familiar with them. Okay, so this is the calculation that we're going to make. This is the variance, or actually the standard deviation of the sampling distribution of that point estimate. And if you're not familiar with that, don't worry, we'll deal with it separately. But essentially what we have to do here is multiply 0.86 by the complement of 0.86, which is 0.14, divided by 200 and get the square root of the whole thing. Okay? So I have it sort of done out there in detail, but essentially what we're going to end up with there is 0.0245. Now, just be careful with your how many decimal places that you might need. I think at this stage, I usually prefer 4 decimal places myself, but in this case, I would sort of recommend going up to 6 decimal places. So we just piece it all together now, essentially. Okay. So calculation of a confidence interval. It's our point estimate plus or minus our quantile. That's plus or minus. So 1.96 times 0.0245. When we multiply that out, we get 0.048. So 0.86 plus or minus 0.048. And there is our values there. 0.812 to 0.908. So it's 81.2% to 90.8%, which is an estimate, essentially, a confidence interval estimate for the true proportion of satisfied customers. Okay, we'll leave it there.